Welcome to the Explainer. Okay, today we're doing something a little bit different. We're stripping away the familiar and looking at some seriously advanced evolutionary mechanics that are literally hiding in plain sight. We're going to look right past that standard, cute waterfowl profile we all know and uncover an absolute biological marvel. We're talking about a creature that operates on a level of complexity that, honestly, very few of us ever actually realize.
So I want you to think about this. What creature possesses a built-in radiator, a bill that's actually more sensitive than your own fingertips, and, wait for it, holds the official, scientifically proven title of the world's funniest animal? I know, it kind of sounds like a fabricated riddle, right? But the answer to all three of those is the duck. Yep, we're going to unpack exactly how this single, everyday animal pulls all of this off, starting right down at the cellular level and zooming all the way out to its massive global footprint.
Section 1. Anatomy of a Marvel. Microscopic Science. Okay, let's dive into this.
So, mechanosensation. This is the conversion of mechanical stimuli into electrical signals by the nervous system. Basically, it's the fundamental mechanics of how an animal feels touch. Now, a team of researchers at Yale University recently looked into dabbling ducks, like your standard mallards, who spend a lot of time feeding in murky, mud-filled water where visibility is literally zero. And they discovered something just incredible. An astonishing 85% of the trigeminal neurons in a duck's bill are low threshold. That means they are hypersensitive to incredibly delicate microscopic touch. To really put that into perspective, when a duck is underwater searching for crustaceans, the tactile feedback it's getting is actually comparable to human fingertips reading Braille. Their bill isn't just a mouth, it's an extraordinarily advanced sensory organ mapping an unseen world.
And to actually stay dry while living these aquatic lives, ducks execute a super meticulous three-step waterproofing process. First, they use that highly sensitive bill we just talked about to extract oil from a specialized organ right near their tail, called the uropygial gland. Next, they methodically spread this oil over literally every single feather on their body. And finally, they sort of zip up these microscopic hair-like structures on their feathers known as barbs and barbules. This creates a seamless, interlocking, hydrophobic barrier. Water literally cannot penetrate down to the skin. It keeps the duck perfectly buoyant, incredibly well-insulated, and completely dry even though they're floating on the water all day long.
Section 2. Surviving the freeze, extreme environments.
Now, have you ever wondered why a duck's bare, fleshy feet don't just freeze solid to the ice of a frozen winter lake? I mean, it's a fair question. Well, it all comes down to this brilliant biological mechanism called countercurrent heat exchange. Here's how it works. Warm arterial blood pumps down from the duck's core body toward its feet. At the exact same time, cool venous blood is traveling up from those freezing extremities. And because the arteries and veins are tightly interwoven, almost like a mesh, that warm descending blood actually heats up the cool ascending blood before it ever hits the duck's core. Meanwhile, the blood that finally does reach the feet is just warm enough to prevent frostbite. They are literally recycling their own body heat through a built-in biological radiator. How cool is that?
And coupled with that internal radiator is a really dense layer of fluffy down feathers hidden safely beneath that waterproof outer zipper we discussed earlier. These down feathers trap pockets of warm air directly against the skin. Plus, over the summer months, ducks aggressively build up these vital fat reserves that serve a dual purpose, acting as both heavy insulation and essential winter fuel. And they pair these remarkable physical traits with behavioral adaptations too. They purposefully huddle tightly together in these big groups to conserve precious body heat whenever those freezing winter winds kick up.
Section 3.
The art of courtship, mating rituals. When springtime hits, male ducks, known as drakes, pull out absolutely all the stops to impress a mate. It's this highly choreographed, high-stakes drama involving exaggerated head bobbing and some really complex vocalizations. But the most famously ridiculous, yet highly effective move is called the trout dance. The drake will dramatically throw his head back and violently shake it, heavily resembling a thrashing swimming trout. It's all to show off his physical fitness and agility. And if he successfully catches a female's attention with all this, the pair will engage in mutual preening, where they carefully groom each other's feathers to build trust and solidify a long-term pair bond. Because here's the thing. In the duck world, the female holds all the power. She is actively and carefully evaluating dominance, courtship displays, and overall genetic quality. In fact, that evolutionary pressure is exactly why male mallards have that iridescent, bright green head and that striking white neck ring. The female is aggressively looking for the brightest, healthiest plumage, because to her, it serves as a direct,
undeniable indicator of genetic superiority for her future ducklings.
Okay, really quick, there is a massive myth regarding their communication that we absolutely need to bust right now. Not all ducks quack. I know, it's crazy. Depending entirely on the species, ducks will whistle, coo, yodel, and even grunt to communicate across the water. And for the specific species that actually do quack, there is this pervasive old urban legend that a duck's quack doesn't echo. That is completely false. The Acoustics Research Center at the University of Salford, alongside the television show Mythbusters, scientifically proved that a duck's quack absolutely does echo. It's just that human ears sometimes have trouble distinguishing the echo from the original sound.
Section 4. Ecosystem Engineers, Global Impact.
So, when a duck dives into the murky depths for food, it's actually acting as highly efficient natural pest control. They devour aquatic snails that would otherwise rapidly destroy local vegetation. And as they digest, they transform into vital nutrient vectors. They excrete nitrogen and phosphorus that heavily fertilize the water column and support the entire microscopic food web. But honestly, their most profound role is that of a seed disperser. Just imagine this. A single tiny seed hitches a ride deep inside those complex waterproof feathers we talked about. The duck then migrates hundreds of miles, lands in a completely barren body of water, and the seed finally drops off. Eventually, that single hitchhiking seed sprouts an entirely new, thriving wetland ecosystem. It's just incredible. Because their biological functions are so deeply intertwined with the environment, ducks serve as crucial, real-time indicators of our planet's ecological health. If you see a sudden, sharp decline in local duck populations, it is an immediate, flashing warning sign of habitat loss or severe water pollution. Conserving their wetland habitats is about far more than just saving waterfowl. It's about preserving the intricate, fragile balance of entire natural ecosystems that strictly rely on them to function and flourish.
Section 5. Human Culture, Cultural Icons.
You really cannot ignore the sheer dominant volume of iconic ducks woven into our literature and pop culture. I mean, we have enduring childhood classics like Beatrix Potter's Jemima Puddle Duck, the brave mother leading the charge in Make Way for Ducklings, and of course, Hans Christian Andersen's transformative Ugly Duckling. Then you have the legendary Donald Duck, and even Marvel's deeply satirical cigar-smoking Howard the Duck. So why do we gravitate toward them so heavily? Well, there was actually a massive psychological study by the University of Hertfordshire called Laugh Lab. They tested thousands of jokes and scientifically proved that ducks are, inherently, the funniest animals. Basically, if you want to make a joke work, put a duck in it.
3 billion. That is a staggering number. And it represents the approximate amount of ducks farmed annually worldwide for meat, eggs, and those vital down feathers that insulate our premium winter jackets and bedding. Our relationship with ducks isn't just some cultural novelty. It's a massive, deeply ingrained global economic partnership that has actively sustained human civilization since the Neolithic era.
Which brings us to our final thought. After exploring their hypersensitive bills that read the unseen water like Braille, their internal blood-warming radiators, those incredibly complex courtship dances, and their profound role in planting entire wetland ecosystems, how has your view of this seemingly ordinary waterfowl evolved? The next time you see them, take a moment to really look. You aren't just looking at a bird swimming in a pond, you're observing a highly resilient, microscopic marvel. Thanks for joining me on this explainer, and keep your curiosity alive.